All right, so now we're going to talk about section 1.3, and the worksheet that goes with this is going to go really fast for you. Linear, remember scatter plots, looking at linear relationships. Let's say you have a set of data, you graph your x and y points, and it looks like this. That's going to show a positive correlation. Notice how they're all kind of moving in the positive direction. So in other words, as x gets larger, so does y. A negative correlation shows that as x gets larger, y gets smaller. And this, if you have dots all over the place, that's obviously there's no correlation between those two values, whatever it is the data is showing. So if the data set shows some kind of a correlation, we can find a line of best fit. Now, you could take a graph and do it by hand, get a straight edge, draw a line, hopefully you'll hit a couple points. You could find the slope of those lines. You could, using y equals mx plus b, find b, write the equation of the line, figure out if that's a good fit, or we could use a graphing calculator because it's so much faster and it's so much more accurate. And I demonstrated in the last video that I can't really show you my graphing calculator screen because I don't know how to make the display on that not so bright. So in other words, my camera won't pick it up because it's too bright. So I'm going to just quickly talk you through some of the problems, or one of the problems on 1.3. If you look at number 4, go ahead and pause now and grab your worksheet so you can look at number 4 on 1.3. The directions for this set says to determine whether the data shows a linear relationship. Well, I'm going to tell you that number 4 is not a linear relationship. I'll show you what so the x values, y values, 3, 6, 10, 12. Those are the x values. Corresponding y values look like this. All right, if this were a linear relationship, first of all, your x's would be going up by the same value. Well, this is 3 plus 3, 6 plus 4, 10 plus 2, 12 plus 4. So that tells me right there that there might be a little bit of a problem. But I want you to look at the relationship of the y's. I mean, well, they're not even, okay, so this goes up by 1, goes up by 3, goes up by 4, and then goes down by 5. Well, you're not going to have a straight line that looks like that, right? So I know that number 4 is not linear. But it looks like number 5, let's look at that problem. Hopefully you're looking at your worksheet while I do this. The x values are 6, 10, 13, 20, 24. So you notice right away, obviously, hopefully, that these are all going up by the same amount every time, up by 4s. That's a good sign. 3, 5, 7, 10, 12. 3 plus 2, 5 plus 2, 7 plus 2. So these are going up by 4. These are going up by a steady pace too. So I know that this is a linear function. Even better than that, I can tell you what the equation of this line is, right? Because isn't y equal to half of x? Isn't 5 equal to half of 10? 7 is equal to half of 14. So I could write the equation, y equals 1/2 x. So then it says, part of the directions say, write an equation of the line of best fit. I already did that. Explain the meaning in the context of this situation. I forgot to put this part. So X is minutes, and Y is cars washed. So if my equation is Y equals 1/2 X, and so what I want to do is interpret the slope. And when it says interpret the slope, that means in the context of this problem, right? What does that mean? What does the slope mean? Well, doesn't this mean that for every minute, which is X, you can wash half of a car? So when they ask you, if they were to ask you to interpret this slope, that's what they're asking for. They're not asking you to tell what the slope is. We can see what the slope is, but what does that slope mean in the context of this particular problem? All right. I want to show you how to do a line of best fit, a scatter plot, and a line of best fit on the graphing calculator. This is the problem that we're going to do. This is the data set that we have. So we're comparing femur length, X, those are my X values, to the height of various people, Y. All these measurements are in centimeters. And I want to know if this data shows a linear relationship. My first thought would be, well, yeah. I mean, the longer your femur is, the taller you are, right? Kind of stands to reason that that would be true. Again, since I cannot show you my calculator, I wanted to have you copy down these steps because you are going to have to do one of these on the test. You're going to do a scatter plot, a linear regression, and we're going to talk about the correlation coefficient that the calculator will give you. So I would, let's see, copy those steps down to this point. Pause right now until you get done with that. When you get done with that part, you're going to hit the play and do the rest of these notes, because that's all that fits in my camera space. Okay? When you do all that, you're going to get a printout on your home screen. And it's going to look like this. Y equals AX plus B. Whatever number A they give you, that's your slope. Y equals MX plus B. Remember that? Okay, hang on a second. Let's try to invade my space. B represents the y-intercept. But this is what I want to talk about right here. I can show you how to find the correlation coefficient by hand, but it takes a while. There's a lot of calculations, a lot of chances for you to make mathematical errors. So we're going to go ahead and let the calculator do it for us because it's so much faster and so much more accurate. When you get this printout on your home screen of your graphing calculator, if the R value is close to 1, positive 1, that means that this is a really good line of best fit and the data shows a positive correlation. If the R value is close to -1, then we know that this line that they gave you is a really good line of best fit, and it shows a strong negative correlation. When you do this problem with the femur and the height, when I did it on my calculator, I got a correlation coefficient of like 0.999 something. Well, that's about as close to 1 as you can get. So there is a positive correlation between the length of the human's femur and the height of that human. We'll be doing more of these when we meet in class. If you are a DLI student, you're going to want to join the meeting. I'll start recording the class on, when do we meet it? Tuesday. So for those of you coming to school on Tuesday, make sure that you have attempted problems on all 3 lessons that we've covered so far, and we'll discuss those on Tuesday. Again, please know if you are struggling, get a hold of me on Teams. We can meet, you and I, face-to-face, work through problems. Call me, text me, whatever you may need to do. Don't sit at home being super frustrated. That's what I'm here for. I'm here to help. Okay, bye.